Now we're on page 7 from chapter 6. This activity is similar to the activity on the previous page with the sine graph, but this is for cosine. So your basic cosine graph, which I'll graph first, looks like this. I'm going to just graph all 3 of these here. So here's your basic cosine graph. Starts at 1. So an arrow here. Then it goes to 0, then -1, 0, and 1. So the graph looks like this. So period, this is going to repeat every 2 pi. Minimum as low as -1. Maximum is 1. The range is low to high, that is -1 to 1. And then the y-intercept is 1. And the x-intercept, it repeats, starts at pi over 2, and it repeats every pi from there. So another way to describe it, we could say it's pi n over 2, where n is an odd integer. And I could say that because it repeats it pi over 2, 3 pi over 2, and so forth. So let's compare this graph to cosine of 2x. So here's cosine of x. I'll go back to my calculator. So if I go cosine of x, it should look like this graph here. But if I go tab and then hit cosine of 2x, what's going to happen is this is going to repeat quicker. So you can see the one in red, how it's spread out. The one in black, it repeats quicker. It's still a cosine graph. It repeats quicker. So I'm going to do this over here in red. So here is y equals cosine of x. Here is y equals cosine of 2x. See, this repeats every 2 pi. The one in black, if you can focus on this, repeats sooner. This repeats every pi. So if I graph this, I'm going to do it like this. 0, pi over 4, pi over 2, 3 pi over 4, and pi. That would be the graph of one cycle, where it took 2 pi to repeat here. This repeats even quicker. This is pi. So if I graph this in red, it's going to start at 1, just like this graph, and then 0, -1, 0, and 1. So the difference between these two graphs, even though they look the same, this repeats quicker than this one. This repeats every 2 pi units. This is pi. So here, this would be pi. Minimum, maximum are the same thing, as is the range. Y-intercept is the same thing. But this is going to repeat, start at pi over 4, then 3 pi over 4. So we could say it's pi n over 4, where n is an odd integer. And then if we try this next graph, which I'll do over here, the difference will be this. If I hit tab and then hit cosine, yeah, the calculator really give a good story here. Cosine of x over 3. If I hit enter, you can see this in purple. This takes a long time to repeat. The one in red repeated every 2 pi, black pi. The one in purple, it takes this whole length before it repeats. So this is actually going to repeat every 6 pi. So if I graph this, and I'm going to explain why in a second, because there's a formula here that will show this. So 0, 6 pi, halfway in between is 3 pi. Halfway in between is 3 pi over 2. If we add these and divide by 2, that's 9 pi over 2. So even though the lengths appear to be the same, as you can see from the graph, this repeats every pi, 2 pi. This will be 6 pi. So again, the shape of the graph looks the same, but the big difference here is, just like you can see the graph in purple, it's going to repeat every 6 pi. 6 pi, -1, 1, -1 and 1. Y-intercept stays the same. And these repeat, starts at 3 pi over 2, then 9 pi over 2. We could generalize it like this. 3 pi n over 2, where n is an odd integer. If I plug in 1, I get 3 pi over 2. If I plug in 3, I get 9 pi over 2. That would describe it all. Now, from looking at these, you guys might have thought, like, how in the world are we getting these periods? So let me give you a formula in general for the period of a sine or cosine function. In general, if the equation's in this form, cosine of bx, to find the period, it's just 2 pi over b. That will give you the period. To show that works, we could look at the ones above here. Look at the coefficient in front of x. For cosine x, the coefficient's 1. 2 pi over 1 is 2 pi. If we look at the next graph, it says cosine of 2x. 2 pi over 2 is pi. In this graph, this is really the same as cosine of 1/3 x. 2 pi divided by 1/3 gets you to 6 pi. Frequency describes the reciprocal of the period. And we could just say it like this. It's 1 over the period. That describes the frequency of a sine or cosine graph. So these problems down here, we don't have to graph these, but it says determine the amplitude and period of each equation. We'll start with the period. So it's just 2 pi over the coefficient of x. That'll give me the period for the first one. Second one, this is really 3 cosine of 1/2 x. So you've got to go 2 pi divided by 1/2. And that's the same as 2 pi times 2, which is 4 pi. Next one, 2 pi divided by 5, or pi over 4. If I multiply by the reciprocal, I will get this. I'll get 8. This one, 2 pi divided by 3, is just 2 pi over 3. Those are the periods. Now, we said amplitude's defined as maximum minus minimum over 2. Unless we have any phase shift or vertical shift, then things might change. But for right now, to find the amplitude, and we could see this if we graph this, you're just going to take the coefficient in front of the trig function. So things could change if there's especially a vertical shift, but until we start dealing with that, we could say in general the amplitude is just the coefficient in front of the trig function. 1/4, 3, 5, and 1/2. Also, the amplitude's never going to be negative because when you go maximum minus minimum over 2, you should get a positive amplitude. These are the notes from page 7 from chapter 6.